in the air, diesels on the water, diesels under the water, diesels on the ground. Every day, diesel power is becoming more and more widely used in construction, logging, road building and maintenance, industry, and agriculture. Caterpillar Tractor Company started building diesels in 1931 and jumped quickly to first place. In 1935, 325,000 diesel horsepower was produced. In 1936, Caterpillar built nearly 50% of all the diesel power manufactured in the United States. In other words, in 3.5 years, Caterpillar moved into a position of acknowledged leadership and has increasingly maintained that leadership in the diesel field. One of the reasons for this tremendous preference for the Caterpillar diesel engine is the simplicity of design. The diesel engine is as simple as A, B, C. To begin with, we have a cylinder and a piston. The cylinder is filled with air at ordinary outdoor pressure and ordinary outdoor temperature. The piston is forced up into the cylinder, compressing the air. When air is compressed, it gets hot. Here is an experiment that shows how compressing air makes it hot. Let's put a thermometer in the base of an ordinary tire pump. No matter how hard we pump with the hose disconnected, we can't get up any pressure. And the thermometer shows that the air inside the pump is cool. But if we connect the hose so that the pump will build up pressure, the red line in the thermometer will climb. Under compression, the air inside that pump gets plenty hot. The greater the pressure, the higher the temperature. In the cylinder of a diesel engine, the compressed air gets hotter than a red-hot stove. Then a fine spray of fuel oil is forced into the space at the top of the cylinder. The hot air sets fire to the fuel. The fuel burns and forms a hot gas, which expands in the cylinder and forces the piston down. After the hot gases have done their work, the exhaust valve in the cylinder is opened and the piston rises again to force out the burnt gases. The exhaust valve shuts. The intake valve opens. Again the piston travels down, drawing fresh air into the cylinder. Now the valves are all closed. The engine starts a new compression stroke. The air gets hot. The fuel is sprayed. It catches fire. The piston is forced down. Over and over again, the expanding gas acts on the piston in the same way that a foot acts on the pedal board of a grindstone. The power is gradual. We have seen the principles of diesel operation. Now, let's see how simply the principles are applied in the Caterpillar engine. On the Caterpillar diesel engine, the fuel system deserves special consideration because of its simple design. Here is a diagram of the fuel system. From the tank, the fuel flows to the transfer pump. The transfer pump forces the fuel through the filters to the injection pump. These pumps force the fuel under only 1,750 pounds pressure per square inch into the fuel.